Hey there, let's dive into Dalton's atomic theory. So, John Dalton was this English chemist who brought back the idea that everything's made of atoms. The ancient Greeks had hinted at it, but Dalton was the first to really break it down scientifically. He said all matter is made of atoms, which are tiny, indivisible, and can't be destroyed. They're the smallest bits of an element that can take part in chemical reactions. All atoms of the same element are the same, while atoms of different elements vary in mass and properties. And remember, during a chemical reaction, atoms just rearrange, none are created or lost. Check out this compound. First up, find the longest carbon chain. If we highlight it in blue, we see it's 4 carbons long, which tells us the parent alkane is butane. If it had 5 carbons, we'd call it pentane. 6 would be hexane, and so on. Now, since this molecule has a double bond, we change the ending from -ane to -ene. The double bond is between the second and third carbons, so we label it as 2 and 3 in front of the name. But wait, there's more. This molecule also has a hydroxyl group of carbon bonded to an oxygen, which is then bonded to a hydrogen. This group gets the suffix -al. Since the carbon with the hydroxyl is attached to the second carbon in the longest chain, we put the number 2 in front. So, the IUPAC name for this compound is 2-butene-2-ol. Remember, we always number the carbon chain to give the hydroxyl group the lowest number possible. While we could have named it 2-methylpropane-2-ol, 2-butene-2-ol is the preferred name because but comes before methyl in alphabetical order. Alkanes react with hydrogen, halogens like chlorine and bromine, and hydrogen halides alcohols have a hydroxyl group, basically a carbon bonded to oxygen and hydrogen, with the formula CnH2n plus 2OH. Thanks to the polar OH bond, they can form hydrogen bonds with other molecules. Depending on these bonds, alcohols can be gases, liquids, or solids at room temperature. For example, methanol and ethanol are liquids, while longer chains like pentanol can be solid. Let's break down functional groups. Alkanes are hydrocarbons with only single bonds, making them saturated. Their formula is CnH2n plus 2, where N is the number of carbons. They're not super reactive, only really getting involved when heated or in light. They can crack into smaller, more useful alkanes or alkenes, and they combust with oxygen to produce carbon dioxide and water. Easy, right? Alkanins can react with hydrogen, halogens like chlorine or bromine, and even hydrogen halides. Alcohols have a hydroxyl group, which is a carbon bonded to an oxygen and a hydrogen, with the formula CnH2n plus 2OH. Thanks to the polar OH bond, alcohols can form hydrogen bonds, making them gases, liquids, or solids at room temperature. For example, methanol and ethanol are liquids, while longer chains like pentanol can be solid. Alkanes are hydrocarbons with only single bonds, making them saturated. Their formula is CnH2n plus 2, since they don't have reactive functional groups. They're not super reactive mostly, just when heated or in light. One interesting thing they can do is cracking, breaking down into smaller, useful alkanes, or alkanes. They can also combust with enough oxygen, producing carbon dioxide and water. Simple, right? Alkanes can react with hydrogen, halogens like chlorine or bromine, and hydrogen halides, alcohols, which have a hydroxyl group, a carbon bonded to an oxygen and hydrogen. Follow the formula CnH2n plus 2OH. Thanks to the polar OH bond, alcohols can form hydrogen bonds with each other and other molecules. This bond strength affects their state at room temperature. Methanol and ethanol are liquids, while longer chains like pentanol can be solids. Alcohols can act like weak acids because of their polar OH bond. They can donate protons, which are just hydrogen atoms. The longer the carbon chain, the weaker the acid gets. For instance, butanol is a stronger acid than methanol. Hey there, welcome to my channel. This is a place where we learn science interactively. Coming up, we're going to learn about one of the most fundamental concepts in chemistry, the atomic structure. But before we do that, are you ready for a quiz? What is the smallest particle of an element that retains the chemical properties of that element? Is it a proton, a neutron, an electron, or an atom? Pause the video here if you want to make a guess. Okay, now back to the video. It's an atom. In fact, this is the very first definition in our chemistry textbook. And that got me thinking, what exactly is an atom? How do we know what an atom is? Do we actually know? And how were scientists able to determine its structure? Let's find out. Let's dive into Dalton's atomic theory. So, John Dalton was this English chemist who brought back the idea that everything's made of atoms. The ancient Greeks had hinted at it, but Dalton was the first to really break it down scientifically. He said all matter is made of atoms, which are tiny, indivisible, and can't be destroyed. They're the smallest bits of an element that can take part in chemical reactions. All atoms of the same element are the same, while atoms of different elements vary in mass and properties. And remember, during a chemical reaction, atoms just rearranged and are created or lost. Dalton's atomic theory worked well for many years, but in the late 19th century, scientists began to discover that atoms are made of smaller particles, which led to a modification of Dalton's atomic theory. In 1911, Hey there, welcome to my channel. In this video, we're going to discuss about an element. But before we start, let me ask you a question. Can you name that element? Alright, here is a clue. It is the most abundant element in the universe. Still can't guess it. How about another clue? It is also the lightest element that has ever been discovered. Still, no ideas. Okay, one more clue. It is highly flammable. Now you got it. It is hydrogen. In today's lesson, we're going to talk about some basic concepts of chemistry like atoms, elements, molecules, and compounds. Let's get started. Atoms are the tiniest bits of ordinary matter, and everything you see and touch is made of them. Yep, even that water you're sipping and the air you're breathing. So, what are they exactly? Atoms are the smallest unit of an element that keeps its chemical properties. Each element has its own type of atom, like hydrogen, the most common element, made of hydrogen atoms, and helium, made of helium atoms. Here's a fun fact. A hydrogen atom is so tiny that you'd need 27 million of them lined up to stretch just 1 inch. Isn't that just mind? Next up, we have elements. Elements are pure substances that cannot be broken down into simpler substances by ordinary chemical means. They are made up of only one type of atom. For example, gold is an element. And, hey, this is your host and we're about to learn chemistry. It's gonna be fun, I promise. Alright, let's get started. First things first, what do we mean by chemistry? Well, simply put, chemistry is the study of matter and its properties as well as how matter changes. So that could be a chemical reaction where you mix two things together and make something new. Or, it could be a change in state, like ice melting into water or water vaporizing into steam. These are all examples of chemical changes. But they're not the only kind of changes that can happen. There's also physical changes, which include changes in the form or appearance of something, but not its chemical composition. An example of this would be if you were to cut paper into smaller pieces. The paper is still just paper, right? But that doesn't mean that chemistry Hey there, let's get ready to learn about animal. You know what animal is? It is a very interesting topic in chemistry. We will discuss it in detail later in this video. But before that, let's take a quick poll. What percentage of the compounds on Earth do you think are organic? Coming up next, an important announcement. And after that, we'll return to our discussion. Alright, how many of you thought that most of the compounds on Earth are organic? Well, if your answer was yes, then you would be wrong. The majority of compounds found on Earth are inorganic. Only a small portion of the compounds found on Earth are organic. But why is this? To understand why, we must first define what organic and inorganic compounds are. Organic compounds are basically carbon-based, right? So, if it has carbon-hydrogen bonds, it's organic. Think methane or propane. On the flip side, inorganic compounds are everything else, like water or table salt. Now, you might think organic compounds are more common on Earth, but that's not the case. Carbon is actually pretty rare. It's only the 15th most abundant element. The big players are hydrogen, helium, oxygen, neon, and iron. Most compounds around us, like water, which is super crucial for life, are inorganic, made up of hydrogen and oxygen. However, just because inorganic compounds make up the bulk of compounds on Earth doesn't mean they are.